This is section 10.3, special products of polynomials. We're going to be talking about the difference of two squares. It's pretty much a shortcut method to cut out foiling in certain situations where you're presented with binomials, where you're multiplying two binomials and they look the way these two look here on your screen. If you have binomials where you have the exact same variable, okay, these are both x's here, and then you have the exact same number, okay, both 5s, and you have a plus sign and a minus sign, those are the only differences between the two binomials, you can use a shortcut called difference of two squares. Okay, before we do the shortcut, let's just go ahead and FOIL it. That's the method that we learned in the last lesson. So we're going to do our first term, x times x, which will give you x squared. Okay, then we're going to do our outer terms, x times negative 5 gives you negative 5x. Then we'll do our inner terms, 5 times x, which gives you positive 5x. And then we're going to do our last term, 5 times negative 5, which gives you negative 25. Okay, so we always go back to the two middle terms. We know that we can combine them. In this case, the negative 5x and the positive 5x, they actually cancel out. So the only thing that you have for your answer is x squared minus 25. So let's talk about the trick here. If I have the difference of two squares, which means I have these special kinds of cases where the variable is the same, the number is the same, the only difference is that there's a plus sign here and a minus sign here, I can go ahead and I can square the first term. The first term is x in both binomials. Okay, I can square that. I can square the last term in both binomials. And I'm always going to have a subtraction sign. That's why we call it the difference of two squares. This is where the subtraction sign comes from. And then this is actually going to give me my final answer here. X squared is x squared. And 5 squared is 25. So sort of a shortcut there for you. Okay, let me go back into mouse mode. Alright, this is it in letter format. You can see that you have an A here and an A here. Okay, all they're doing is saying, okay, square the first term. Okay, well if you square a, it's going to be a squared. Okay, you're using the subtraction symbol. Okay, that's why we call it the difference of two squares. And then you square the last term, which is b. b squared is b squared. Okay, so sometimes kids look at this and they get confused, but really it's the same thing that we just did with the numbers in their place. Alright, and we like to say, when in doubt, FOIL it out. So if you're not sure, you don't recognize the special case, okay, you know how to FOIL this and you can always go back to that. Okay, so here's another case where we have the difference of two squares. So let's do it using the method that we just learned. Okay, first terms are both x, last terms are both 7, and then you have a plus and a minus sign here. So the binomials are pretty much identical except one's plus, one's minus. Okay, when you see that, you can square the first term. Okay, so you're going to have x squared. Square the second term, so it's 7 squared, and you're going to have a subtraction sign in the middle. X squared remains the same, it's going to be x squared. Subtraction sign drops down, and then 7 to the second power, or 7 squared, is going to give you 49. And it's as simple as that. And if you FOILed this out, okay, we can do that real quick just to prove it. Okay, let's FOIL it out. X times x, that's going to give you x squared. X times negative 7 gives you negative 7x. Okay, let's do our inner term, 7 times x, which gives you positive 7x. And then our last term is 7 times negative 7, which gives you negative 49. Okay, the two middle terms, when you combine them, they cross out, and you are left with x squared minus 49. So you can see which no matter way you do it, it's going to give you the same answer. Okay, if you can recognize the special case and you want to try to do it that way, feel free. It'll save you a little bit of time. But if you're not sure, okay, or when in doubt, just FOIL it out. Okay, let's do the special case here using the difference of two squares. Okay, so we are going to square the first term. So we're going to have x squared. Let's square that second term, 12 squared, put a minus sign in the middle. Okay, x squared will remain as x squared. The minus sign drops down. And then 12 to the second power is 12 times 12, which gives you 144. So there you have it. Okay, complete, done. And definitely a little bit shorter than the FOIL method. Okie dokie, so let's take a look at this one. Okay, I think we have two. Yeah, okay, we got two on this slide. All right, so let's take a look at the first one here. Okay, we have the 3x and the 3x, we have the 10 and the 10, and then we have the opposite signs. So let's square this. Now be careful here. Okay, we're going to square everything. So we have 3 squared, x squared. Okay, put a minus in there. Remember, it's the difference. Okay, the minus. Okay, and then we're going to square the 10, squaring that last term. Okay, 10 squared. All right, so you're going to go through and solve this. All right, so you have 3 squared, 3 times 3, which gives you 9. X squared, can't really do much with that, so it's x squared. Put your minus sign in, and then 10 squared, which gives you 100. Okay, once again, if you wanted to, you could FOIL it out. You could check it and make sure that it's right. Okay, let's do it again. Okay, we're going to have 4 squared, okay, and x squared. Put your minus sign in, and then your last term, 7 squared. Okay, now let's solve it. 4 times 4, or 4 squared, whoops, gives you 16. X squared remains as x squared. Put your minus sign in, and then you have 7 squared. 7 squared is 49. Okay, and that is it for this portion of the lesson.